Hello.
Hello.
Hello, folks. We'll wait another couple of minutes until we converge on population here, and then we can start. Is there anyone new that wants to present themselves? Maybe.
Was there anyone who's old and wants to keep quiet about who they are?
I'd like to not speak and say anything. No, I'm just joking.
Too late. I'm sorry, Keith. You just ambushed yourself.
Oh, darn.
I definitely qualify for the old part.
Oh. Yeah, it's kind of weird. I was on a chat a few years ago now, and someone actually referred to me as a greybeard, and it was okay. Yeah, you're probably right. I mean, literally, when I grow it out, it is actually grey these days. But I've just been around the houses enough that I just kind of qualify, which is, I suppose, all right.
Happens to the best of us. Keep it shaved.
Yeah, I know. Well, my wife's pretty clear about that. It stays generally pretty shaved.
Glad to know you have your priorities straight.
Yeah, I've been married for nearly 30 years, right? We're well past that. Okay.
Yep.
Okay, I think we can start. What do you think? This is the page where you can add your name to and see the agenda and previous meetings and whatnot. Please add yourself to the list. And what do we have today is Usama. Specification of SCON attestation. Continue conversation from last meeting. I wasn't there last meeting, so I don't know exactly where to pick up the threads, but Usama knows. Okay, Greg, please go ahead.
Me, go ahead. I didn't refresh my memory as to exactly where we left off last time, so I will let Osama catch us up. Sorry about that.
Okay.
May I also request just a couple of minutes to tell people about something?
Yeah.
It could be either the beginning or the end. I don't mind at all, but just so I can.
Usama, what do you think? Do you want to start?
Yeah, it's fine. Mike, go ahead. We can.
Okay, it is very, very short. So, a while ago, the governing board agreed that one of the things we need to look at for the wider ecosystem is business models around attestation services. So obviously in this group, we're mainly focused on the technical, and that's just fine. But A, there are some technical things which are relevant to that. And B, you may either have a personal interest or have people who are in your business or organization who are also interested in how all this works with, regulators and foundations and consortiums and auditors and all those sorts of things. And for instance, I'm aware of the work the GRC group has done on attestation services. And I'm putting together basically a working group, and I hope to have a kind of a first shot at a kind of white paper discussion group, maybe by the end of this week, early next week. I'll share it with folks on this call, but also more broadly. If you or any of your colleagues are interested, please join in and let's get things kicked off. I just wanted to let everyone know about it because this is the Attestation SIG group, and it's therefore the right place to discuss it.
Can you describe the intended audience and where this is intended to go and achieve what?
Yeah, no, that's a very good question. It's really to help us in the Confidential Computer Consortium work out what we think are the key features of an attestation service, and to help the ecosystem understand what they should be looking for when they're choosing an attestation service, whether it's running themselves or whether an ISV runs it or a CSP runs it or a silicon vendor runs it. What are the things you can expect? What should you not want? What should you want? And if you're thinking of running an attestation service yourself, why would that work? Does it make sense for a regulator to run it, or a government to run it, or for the CCC to run it, or the LF to run it, or the Eclipse Foundation to run it, or for Mark Novak to run it? I don't know. So it's intended to raise these questions. And I've already got sort of 11 properties that I think an attestation service might want to have, which kind of encompass some of the things in the GRC document, although I haven't fully regularized them yet. And so that's kind of where we are.
Mike, could you please share the document pointer so that we can have a look?
The answer to that is not yet. So I hope to have something kind of the end of this week, early next week, at which point I will share it. It's just not quite ready yet. This is kind of a heads up. Sorry.
No problems. Where are you going to share it? The mailing list, the Slack channel?
I will certainly send it to the mailing list, a variety of mailing lists, and I'll make sure it gets onto the Slack channel as well.
Awesome. Thanks very much.
Thank you.
Usama, you have your...
Mike.
Do you want to ask a question?
Sorry, Thomas, are you asking me?
I saw is raised, so I wonder whether you want to ask.
Yeah. So yeah, I have a quick question for Mike. So what you are explaining, is it supposed to be who should be running that attestation service, or is it exploring like the design space or the current existing practices that who is running the attestation service in, let's say, XYZ solutions or all existing solutions? Which one?
So I'm not exploring the existing solutions. I suspect that I'm kind of exploring the space of where all those solutions might look like. And one of the things we might want to do is actually say, well, I would fit this solution into this box, this solution into this box. But it's also intended to help people understand, look, firstly, I'm an ISV. Is it worth my while doing this? And a customer, I'm a customer. Should I trust this? And what are the criteria I should do? And I think we need more attestation services, but nobody knows why or what the value add is or the return on investment. And an intention is to get people thinking and talking about that and discussing it.
Right. Interesting. Thanks.
Cool. Thank you.
Cool. Thank you very much. Then we can hand over to Usama, or if there's any other question, we can take those. And no? So, Usama.
Okay. So, all right. Okay, so basically, a quick recap to what we did discuss last time. for those who were not here, or just to recall those for those who were here. This is the ongoing project on attested TLS, and more specifically on the formal verification. So status update on that, and joint work with Thomas, Hannes, and Simon so far. Others are, of course, very welcome to join. So it's something that we have started looking into. A lot of questions still are there to be resolved. So it's basically, I think, little presentation and more of discussion and more of trying to answer the open questions. So agenda is last time, so a general overview, and then I will go a bit more into scone architecture in detail. And the motivation, as I discussed last time, quick review. So there are three basic motivations: standardization in the TLS working group that this draft lies has adoption process, which has mandated the formal verification for non-trivial kind of changes for any changes to the TLS standard 1.3. And this draft definitely falls among that. Technically, we all know that remote attestation is a fundamental building block of confidential computing. It needs formal verification and ethical and legal, because confidential computing is increasingly being used in the AI applications, and there are various regulations for that, AI Act, GDPR, and so on, whatever the region is. Oops. Okay, so very, very top level view to see where we stand and what we have done and where we are heading to is that we have application level view. And then below that, we have the transport protocols like TLS and other protocols. And then below that, we have the systems architecture. Here where we have all the trusted execution environments, and particularly we have explored the Intel SGX, TDX, and ARM CCK. Ante Direk in, I think, last month also presented, and Peter also presented this AMD SEV SNP. So we have kind of explored this in a lot of detail for major kind of trusted execution environments. So there is one from China which can also be explored, but pretty much we know now this space with full confidence. This is where we are heading to now, the trusted, the transport layer security TLS. And now there is a big intersection between these two and a lot of interaction between these two. And then the future is basically that we will go to the application layer or the application level to understand what's going on in the application and how these two interact with that application. So we are somewhere in between this point and trying to see how the interaction of these two basically happens. A little bit of application also, specifically in Scone, because it's post handshake, so it uses some of the application layer security concepts. So just a top level view to give you an idea where we are heading towards. So going from the bottom to the top to integrate all the things and have an integrated formal verification for each. Firstly, individually, so we dealt with this. Now we are trying to do the combination of this, and then eventually we will have all of the three combined together, hopefully. Okay, so generic architecture, we saw it last time. A very, very top level view here is that the workload is the tester, secret broker is the relying party, this is the verifier, and then we have the workload owner who is providing this workload, and the verifier owner who is governing this verifier. And the legend on the right shows, on the left, sorry, shows this temporal behavior, how it happens in time. This step happens first, and then this second, third, and fourth. And there are two perspectives, the two layers that I showed on the last slide. So remote attestation mostly coming from the systems architecture, and TLS from the transport protocols, because I believe all the solutions that exist in the space use TLS, or at least most of them. I'm not aware of anyone which uses other protocol other than TLS. For the network, I mean, of course, there is for devices, we can use SPDM. So for network, TLS is the most commonly used protocol. So from TLS perspective, there are client and server. Client by definition is the initiator. And here I have both the roles for each of the 4 steps. Here, verifier owner, for instance, is acting as a client, verifier is acting at the server, and so on. And for remote attestation, the arrows are showing the direction of going from the verifying relying party, combining the two roles of the verifier and the relying party, and going towards the attester. And after successful attestation, it will pass on some secret, which is shown in the red. For instance, in the first case, this verifier owner acts as the verifying relying party, and verifier in this case is the attester for this. And after checking it, it will pass on configuration that it's running inside the trusted execution environment. Just a tabular description of this, verifying relying parties, attester, and after successful attestation in each stage, what will be passed on or provisioned to the attester. For instance, in first case, the configuration, security policy, and secret, security policy, and then configurations of secrets. Secret broker in the general sense, because it can be a key broker, it can be a key, or it can be some configuration or something else. So just a general terminology. Then we quickly had a look at the Scone architecture, which is basically combining the two blocks, secret broker and verifier. Greg had a comment. I forgot to add this yet, so sorry for that. So basically, it's combining these two roles, secret broker and verifier, into one block, which is the CAS, the configuration and attestation service. And then we have the 4 steps in the previous slide, generally reduced to 3 because now they are single entity, this named as the CAS. So this again are the TLS roles as well as the verification, the remote attestation roles, all shown. Simply a reduction of that to this architecture. Okay, so this slide, I think we have seen many times. Exploring the whole design space of attested TLS, combining attestation into TLS. How we can do it, there are 3 ways. This is the TLS handshake protocol. And this is the main step in the remote attestation. The other step being, assume that the assumption here is that the claims are collected recently and are protected by the attesting environment. And then the main thing is to do is the signing of these claims, and which is shown here. So if we do these signature and afterwards it will be transported. So that's the cryptographic protection of that, of these claims. If we do it before the TLS handshake starts, the time going to the right, that's pre-handshake, in between TLS handshake, intra, and after TLS is post. And just in case you have any question or comment, please feel free to interrupt me. Otherwise, I will just quickly recap what we had discussed last time.
Yeah, I got a question. Can you hear me, Osama?
Yeah, yeah, I hear you.
Yeah. Going back to the previous slide,
This one, or
yeah, that one's fine.
Okay.
No, not this one here. Yes.
Okay.
So we didn't get to talk to it a lot during the side session you held last week, but at IETF. But the type of evidence, is there a way to? Do you plan a way to indicate that in the as part of the TLS handshake? So I mean, if you look at this, the way it's being proposed in IETF, I read the document as general attested TLS. But I mean, if you're talking about specifically in the context of CC, right? I mean, if you're talking like, for instance, like a lift and shift scenario for workload transfer, or whatever reason TEEs must communicate with each other using attested TLS. The evidence, the evidence required for that may be different from an attestation in another for attested TLS in another for another purpose, where relying party is trying to determine the security state of the endpoint for some other reason. So, I mean, is there a way to actually tailor evidence in attested TLS, or is that something that's beyond the scope of the standard?
Okay, so for this thing, I will say the standard is basically, or the proposed standard is not yet a standard. So is talking about pre-handshake attestation and intra-handshake attestation. So these are the 2 things which are which we are trying to standardize. And basically the slide, what it is so you talked about two workloads, right? So, and the evidence format can be different and can be something, it still needs to be protected. Either it's there will be some cryptographic mechanism. I have used here signatures. For instance, if they are within the same platform, that can be simply a MAC. And that's one point I raised also to the SCON that they were doing wrong. That they had if both the parties or both workloads in your example, as you were saying, they are on the same platform, why not use the MAC rather than the signatures? So this slide is only showing a typical kind of cryptographic protection. To be more general, it can be said that, okay, so cryptographic, let's say, integrity and authentication protection for the evidence or the claims. But all this slide is saying is that whatever the claims evidence format is, it doesn't matter. So this is the point in time at which we protect these claims with some cryptographic mechanism, be it signatures, digital signatures, or be it MAC or anything else. I think these are the only two options to protect that.
Okay, so maybe let me rephrase it. Yes, I understand that what you just said. It makes perfect sense, but there's nothing in the slide that allows a verifier or relying party to indicate what kind of evidence. What kind of evidence?
Nothing in what?
Can I?
Yeah. Go ahead. Maybe.
Yeah. So the ATLS draft has a negotiation mechanism that uses the client and server LO to actually define which evidence or attestation result format will be used by both parties. And so you have you put forward what you can do to the other end, and the other end can say, okay, I can consume this and this and that, and then you choose which one. So yes, there is a way to, so for an endpoint that supports multiple evidence format or multiple attestation and attestation results, evidence and attestation results formats to negotiate with the other peer what to use in a specific in a specific case. Yes.
Okay. Thanks, Thomas.
Yeah. Right.
And Tomas, are you referring specifically to a pre-handshake scenario or also the
pre-handshake? What we categorize as pre-handshake is attestation results, and intra-handshake is background check kind of evidence. So we support both in the attested TLS proposal.
Okay, I think it's kind of orthogonal to background check versus passport, though, right? Like either could be sent in either phase.
Well, yes, you're right, in a sense that you're not forced to have evidence that is nonced, but and you could have timestamped evidence as well. So you could have potentially evidence that is produced in pre-handshake phase. But yeah, what is sort of orthogonal, but what we are seeing is that the models are pretty much mapping like that. So you have passport mode that is pre-handshake, and you have background check that is intra. At least in the most well, in the cases that we have been considering. If you have any counterexample, I'm happy to hear.
I mean, we have a post-handshake protocol for our split trust encryption tool, and it does currently send attestation evidence, but it was made to extend easily, and we're considering extending it to also use an attestation results.
Right. Yeah. And then the question that you always have there is, because the attestation results are pre-computed, then how you do the channel binding, right? Because you have to have an outer layer where you stick the nonce if you want to have.
I think that was the part that I was highlighting. I don't think that it needs to be pre-computed.
The passport, you mean?
Right.
Probably we can, Thomas, make this discussion pending, because the SCON solution itself is post-handshake. So we will have this within this.
Sure.
If you like.
Lower end. Good.
Okay. So just to recap Giri's question. So the client hello and server hello, as Thomas mentioned, has these extensions where the two parties are negotiating. Client is describing what it formats the verifier can support, and server will then choose and put this as an extension to this. And before that, so this slide is not meant to be adding attestation, just an idea to recap on that question. And for post handshake, I will come to it because scone is all post handshake. Okay, so this is the standard TLS with client authentication on top of the base or the very basic TLS. So it has an additional message, this certificate request, with which the server will request the certificate from the client, and then the client will send this certificate and certificate verify. And at the point of client finished, we have the exported keying material available, which can be exported to the application layer and then used as a random set of bits. So all standard TLS, no changes yet. So we have remote attestation, and the core idea here is 3 steps. A tester generates an evidence, generation of evidence here, and then it transmits the evidence, and then the verifying relying party, combining the 2 things, will then appraise the evidence. A very simplistic core idea of what is done within remote attestation. And now we have TLS, we have remote attestation. What we need to do is to combine the 2. And that's what attested TLS does. And this is showing the generic attested TLS protocol, meaning that the 3 things that we had seen in the previous slide, pre, intra, and post, all of them are combined together. Kind of this thing is on top of the TLS protocol. And I'm not showing the 2 steps, namely this generation and appraisal. It's only showing the transmission of the evidence. So there are like, for each of them, it can be put inside different places, which is for the pre and intra, it's the most appropriate place is this certificate message as an extension to the certificate message. So it can be it can be an extension also to the certificate itself rather than the certificate message, as in Intel's RATLS, where this certificate itself is extended with that evidence. And for post-handshake attestation, what happens here is that we have this exported keying materials available at this point in time, and then they are used as part of the evidence and then signed along. So I will come to the details in a couple of slides. So this is the whole summary of the whole thing, that basically we transport it at this point in time for pre and intra, and for post it's done after the TLS protocol has basically finished. So this is the end of the TLS handshake protocol, and it's then done afterwards. Okay. Protocol for scone. Scone is a post-handshake attestation solution, as I already mentioned. And the changes to the generic protocol is that it has this. So this is the identity key of the client. This is the identity key of the server. In case of scone, basically, this is an ephemeral key represented by this EK. And then the certificate in this case is a self-signed certificate. So 2.5, the certificate message shown here will be not containing the evidence because it is post-handshake. It will be afterwards. And in 2.6, we have the certificate verify. And since we have this key, so the private part will sign the log up to this point, the running hash of the messages, and to provide the proof of possession or the key confirmation. However, it is unspecified in scone that how actually they transmit that evidence. It could be transmitted as an application data after the end of the protocol. For instance, here, it could also be transported as the post-handshake authentication and so on. So there are various ways. It doesn't specify exactly how this is transmitted. Okay, let's see now the architecture in a little bit of more detail. We have seen this slide. And scone, in addition to the 2 coating enclaves provided by Intel, which is the decap and EPID coating enclaves, it also provides its own coating enclave, which is named the scone coating enclave. And corresponding to that coating enclave, the code it generates in Intel's terminology is called the scone code. So it's unclear in the specifications what exactly is the difference between the decap coating enclave and the scone coating enclave, and correspondingly the format of the code and the scone code and the decap code That's where it's necessary to give complete specifications, and that's what I was mentioning, that we have a number of open questions in the specifications. Okay, so a little bit of more details now about the same figure which I had here. So modified a little bit more to give more context of what happens. So these are the so Intel SGX components. Forget about that for a while. So just think of it as the confidential computing hardware platform. And also this one, what's important here is to understand that this application which will be measured is not only the application, but also the SCOAN runtime in addition to that application provided by the application owner. And in the second platform, which is actually showing this one, so platform 2, and assumption here is that they are all on the separate platforms. So the CAS instance also again has this SCOAN runtime in addition to the CAS. So the point I want to make here is basically that I will have also in another slide is that how exactly will a app owner check that the measurement he is giving for, so what he is getting is not the measurement of the application alone. So he cannot really verify and double check that it is his own application. It's the measurement of SCOAN runtime plus or joined together with the application that he provided. So, and that SCOAN is not an open source solution. So it's unclear how can I, independent of SCOAN, verify that this is the measurement of my code, because I don't have this part. So how do I actually ensure that this is actually my own code or measurement of my own application and not something modified? Then the communication with the two parties which were shown here in the last slide, workload owner and verifier owner, is done via SCOAN CLI. And it has embedded itself all the reference values and the certificates, meaning the endorsements and the reference values for this enclave, that is the CAS plus this SCOAN runtime, with which it can verify that it's talking to the right party, again provided by SCOAN. We have to trust them for doing this all correctly because the code is not available. Similar step happens here, workload owner, when it wants to check that the CAS is running inside this confidential computing environment. In this case, this is the CAS owner, SCOAN CLI he runs, and it's all embedded in here to be able to check. So then there are some details about Intel SGX that we can skip for this specific presentation. Okay, so yeah, so now there are three steps: generation, transmission, and appraisal. And then I talked a little bit about transmission already, that it will be transmitted at the end of the TLS handshake, and it's unspecified how exactly this is done. So the other thing is this generation of remote evidence, and the stage 3 basically refers to these 3 stages, or going back even these 3 stages in the block diagram or the architecture diagram. So I'm going to talk only about the stage 3 and the specifications which are not yet available to us. And the other 2 are actually even more unspecified and has much more open questions. Anyway, let's look at one part at least. So to get a feeling of how this is supposed to work. So this is all the steps for the remote attestation. So for the remote evidence, how it's generated, namely the code, how it's generated. The interesting point here is the same that I have already mentioned. That is, the enclave basically contains the application as well as the runtime. And this key, which is shown here, the ephemeral key, is used to do all the processing with or the communication with the quoting enclave, get back the local evidence, and then so get the local evidence from here and then provide it to the quoting enclave to get back the remote evidence, which includes the endorsements, that is the PCK certs and so on. And then this is the evidence then that will be used for the appraisal. That is namely this code. Okay, so the important specifications, what should be, so one of the questions in our mind was what exactly should be specified for such a solution to work? And one important thing here is a report data field, which must be specified exactly because this has every guarantee is basically coming from this, how it is constructed, what does it contain, and what its how the security will be dependent. Everything in security basically will be dependent on this. And many solutions I have seen also do not specify this. Anyway, and the idea here is that it basically takes the hash of this auth data, and auth data is shown here. And then the remaining bits are set to 0, and that's it. That forms the 64 bytes required for the report data. And let's see now how this auth data is constructed. It's contains the version of the auth data, and then the upper protocol version and the lower protocol version. And this version basically represents the protocol between Scone runtime and CAS. And one thing, if you remember previously, so from the protocol, I'm going back a few slides to emphasize this. So it uses exporter key material, and which is at this point in time, which means that it contains the log up to this finished message, and it does not contain this client certificate. So that's why this is included as a separate thing within the report data. However, we believe that it's not the client cert, it's basically the SPKI, which is, I think I have this as the next point. Yeah, and the protocols that was basically for this, they do not specify how the two entities come up with the agreement of these versions. And for this client cert, basically it's not cert, it's basically an SPKI as defined in RFC 5280, which is the subject public key information, I think, or something. I forgot what is I. But anyway, the idea is basically it's a raw public key and the algorithm, that's it. So it's not actually a cert. And then in the specifications, they call it nonce somehow from the TLS, which is, to our understanding, basically this EKM, the exported key material from RFC 5705 and updated by RFC 8446, which is basically representing this thing that given the label and the context, it will generate this EKM at this point in time, accounting the hash of all of the messages up to this point. So basically, this, what they call as nonce, is basically this EKM, the exporter key material, which to our understanding until now. Okay, and then why I say that report data is very important to be specified for all solutions, because this is where we are getting something which is actually signed by the hardware. Other than that, so it's the only user provided field. So everything else in the Intel SGX is coming from somewhere else, which means that it's all hardware defined. So everything here, PCK certs, how the code is formed, and everything is pretty much well defined. So the only two things are who is the target information for this, which is it's generated for this quoting enclave, and what is the report data field, the two important things to be specified. And then Scone basically claims that, hey, or several of the properties are basically attested. And here is what I would need to emphasize, that we really need to define. RFC 9334 does not define what attestation itself is. It talks a lot about all the verifier and this and blah, blah, blah. It does not define really what is attestation itself. And when exactly do we say that something or some property is attested? And then it's open to everyone to claim that, hey, we are attesting this, we are attesting XYZ, we are testing this and this and this. So there is a long list of properties which S-Contain claims that they attest. However, there is no evidence of this in the auth data specifications that they have provided. And of course, then it's not attested, because it's not going to be, report data is the only user provided field. And this is not attested by default, the state at rest. And it's unclear to us at the moment how they can claim that all these properties are attested unless they have some other definition of attestation, which would then be of course, like something we need to standardize as well. So the key idea here being the hardware has no, or it's not hardware attestation of these properties. Even if they are attesting it, somehow it's not clear from the specifications how exactly this property can be attested. So if someone has any thoughts or ideas, feel free to let me know. But to my understanding, this is basically not the case that this is being attested. It could be something that they check, but it's, I think, not good to say that it is attested. So everything that appears here can be said to be, so this can be said to be, this is the public key. So this we can call as the key attestation. So this part, this is creating the kind of channel binding between the TLS and the remote attestation, that session. So which has gone through this kind of communication, which has, at this point in time, they have established a shared secret, which is now also included in all of these logs, as well as what negotiation happened from attestation perspective, if there is any. So that's also logged. So everything up to this point was logged. So yeah, that's included as part of this. And then it is creating a binding between this session, which we are talking about, the TLS session, which is ongoing, to the remote attestation. And so this is more of a channel binder than a nonce. But anyway, so this is doing the channel binding. This is providing the public key link to, or the key attestation for that. But there is no evidence that state at rest is attested, and all other properties that are claimed are, in our opinion, actually not attested. They can be checked or something else, but not attested. Okay. Then the final part is this appraisal of remote evidence. So we talked about generation, and in generation specifically about the report data and what the hardware signs and what we call as attested. And previously I talked about how it is transported. Now is the final stage, which is this appraisal part. And all of this, I'm talking only about stage 3. That is between, stage 3 was, as a reminder, just between SCOAN runtime and CAS. So the two platforms, the workload and the CAS instance. So in this case, the verifier is this CAS. This is going to check the measurements of this whole enclave. And the way it happens is that it has so remote evidence coming in the form of this quote, and then the remote verifying relying party is this CAS, as I showed in the diagram. And then we have the endorser, reference value provider, and verifier owner roles. Endorsements are all these certificates, the PCK certs and the CRLs, revocation lists. And then we have the reference value providers. For TCP info, Intel is the provider for this. For the quoting enclave, identity, it's the quoting enclave owner. So if it is SCOAN quoting enclave, I mentioned that there are 3 quoting enclaves now in SCOAN. So APID quoting enclave, DCAP. So if it's APID and DCAP, it's Intel. If it's SCOAN quoting enclave, then it's sContain. And then there are these app measurements and SVNs. Here is again the issue that I have written here app owner, but this is still a question mark, which is that the app owner may not really be the reference value provider, meaning that, yeah.
Can I interrupt you? There's Jerry that wants to raise his hand, maybe wants to ask a question on this specific slide.
Yeah, thank you.
Okay, sure, go ahead.
Yeah, so you previously established that.
Can you be a bit loud?
Sorry, I apologize.
Yeah. Yes, this is great.
Yeah, okay. You had previously established that the nonce is not really a nonce. It's just client generated EKM, which is not necessarily related to freshness, in my opinion, because of session continuity. So if the appraisal,
so why it is not the
it may not. So here's the thing, right? freshness freshness should freshness ideally would be related to challenge data that originates from the verifier, right? In this case, that's not that may not necessarily be the case, particularly if EKM is retained across due to TLS session continuity. It may not really be. It may be stale evidence that you're getting, right? I mean, or at least you don't have proof that it's fresh evidence just by the yeah. So the thing is, the verifier will have an appraisal policy. My question is, if that appraisal policy includes verifying freshness with respect to a verifier created nonce, it sounds like it'll reject the attestation every single time. Is that correct? Look, if you see it, the far right appraisal policy, okay.
So
The appraisal, if the appraisal policy, the appraisal policy may include criterion such as verify freshness of the attestation evidence with respect to a verifier generated nonce. That is not that is not happening in this case. So the verifier could conceivably reject the attestation evidence every single time, right? So
let me try to think over this. So what you are saying is let's assume there is a verifying underlying party rather than the verifier, right?
Okay.
So what you are saying is that if this provides a nonce and its policy says for verification that this nonce should be a part of that evidence, then you are saying that this is not happening. So every evidence will be rejected because
exactly. And I mean, that's consistent with what we defined in RFC 9334. And so I'm just saying that this is what I believe what I'm seeing here is that if you're talking about the formal validation, right? It's an end-to-end validation. So I'd contend that the appraisal policy should be considering only verifier generated nonces, not client generated nonces. And since the SCONE system doesn't do that, then the attestation has to be rejected every single time. Particularly if we want to stay consistent with 9334. So
yeah. In where in the just as I mentioned before in the beginning, so there are many open questions, and this is what we have put together to start the discussions with S-Contain that, hey, how you are doing it. So we have many questions open to them already posted. So the response is very, very slow. But anyway, so what do you think? Where exactly do you think this, assuming that this role is the verifier plus the relying party, so this will generate the nonce, right? So assuming both are combined together, very simplistic behavior.
Yeah.
So where will you put the nonce in? So would you reuse the nonce sent as so one way to do it in my mind was a kind of an optimization, which is the server already sends a nonce, which is inside this server hello. Why not use the same nonce in the evidence to provide freshness? So this is very much, so it already has that, right?
You can do that. You could do that, and also EAT allows for the EAT standard allows for, one of a better word, array of nonces if you want to keep them separate between what the servers, if you have a distinction between the server and the verifier. But here, I think that if you're communicating with the SCONE team, what they're saying, I think what they're sending is in contradiction with the 9334 approach to recommended approaches to freshness, and therefore Giri,
I don't think that the RFC 9334 restricts to nonce only. So it has three different freshness mechanisms, times nonces, and the epoch IDs, I think so. Whatever name.
But they're not using any of them, right? I mean, they're using EKM, which could be stale data because of TLS session continuity. So that's where I think we're getting. That's EKM can be used for channel binding, but it shouldn't be, for binding to the session, but it shouldn't be used for nonce, in my opinion. or it shouldn't be used for challenge data at all, right? So, I mean, it's I think basically you fail the formal validation of the system just because of that. Because because the if the verifier is designed with an appraisal policy, we would expect the appraisal policy would require at least one of the forms of freshness that's defined in 9334. And in my opinion, they're written to be general enough to cover all cases.
Giri.
Yeah, of course. Like this is not something that they. Sorry, Thomas.
Yeah, go ahead.
No, sorry, I just wanted to check with Giri that is proposal or what is implied by what he is saying is that if a server-generated nonce is mixed into the rest, right, with the channel binary as well, that would be sufficient, right?
That would be fine too, and that's kind of what they do in FIDO. If you study that, they have client data, and client data is mixed with the server generated challenge. So you can certainly do that.
Okay, because the problem here is practical in the sense that I know that it has multi-nonce and so does Epoch ID, but the slots here are limited. So Intel has one single group where you can stash all the stuff, and ARM CCA is the same, as you well know.
Yeah.
There must be a way to actually accumulate all this material into one slot that is allowed by the API.
Yeah, I mean, you could do that too. In my opinion, you could do server generated challenge data and mix it with the EKM and use that as the nonce and the attestation evidence. But that's not even what's happening here. So okay.
So I wanted to check whether this was your understanding, and okay, cool.
All right,
Thomas, my question, just to clarify, just to understand what he's saying. So isn't it that so this nonce, which is actually a TLS nonce, but this is providing the freshness already inside. This is also included in the EKM, right? Because EKM is taking care of this server hello, which has this extension of this nonce. Even if we do not have, let's say, in this model a separate nonce for attestation, if we reuse that nonce from server hello as part of the EKM, which is then a part of evidence, isn't it sufficient? What do you think?
So here's my problem with that is that my understanding of TLS session continuity is that EKM can be carried over. So you're not getting freshness for an attestation on demand, or for an attestation related to this TLS handshake. If that's the case, that's why it's not a foolproof mechanism for ensuring freshness.
So what is Jerry saying is that once you have established a TLS tunnel, then you could potentially have multiple remote attestation sessions that are bound to the same TLS channel. So, and because the same you create the same AKM, then you fail to provide freshness to the N+1 session, right? So
Okay. Yeah. Now I get it. Right. I completely agree with you. Yeah, that's absolutely right.
Okay, thanks, guys. I think we're all on the same page.
Another problem that Jonathan highlighted in the last week in IETF is that basically in the EKM they are not using they are using the empty. There is for EKM we need 3 inputs. One of them is the label, another one is the context. They use an empty label, and with the empty label you can so you are basically having the same value whenever you generate it, and then it's not a unique and not a nonce. So that's why also is not a recommended practice that they are basically using. Okay. Appraisal policy, as Giri has already mentioned. So this can have freshness or many other criteria that whatever we want. But the main point here was that this app owner not really being the reference value provider, and this may not be acceptable in many cases, as we talked about the legal and other perspectives. Anyway, just concluding quickly, the discussion and the security analysis, we need to trust costs in this solution. Bootstrapping costs is just believed to be correct, and there is no way to check it. And as I mentioned, so the figure that the big figure that I showed, so that was assuming that maybe I quickly jump to that. So this one, we are assuming that they are on the different platforms, this application and the CAS. So in case they are on the same platform, we can simply use local attestation. There is no need to use the signatures and all this complexity for that. So their solution was actually using remote attestation in all cases, even if both of them are on the same platform. And local attestation based on Mac is much faster, and we recommended them, and they have changed it now to support local attestation for this case. And again, in stage 3, there is a, so I talked about 3 different quoting enclaves, and the specifications that we received from them basically had a contradictory order of quoting enclave verification. For instance, as a verifier, if it wants to, so as a verifier CAS basically can expect 3 different kinds of quotes, namely the SCOAN quote, APID quote, and the DCAP quote. So in which order is it going to evaluate these quotes? So that order itself was contradictory in the specifications. And as I have mentioned, so this is a closed source solution and underspecified. So we were not able to yet start with any kind of formal verification. We have tried to specify it just in English and so on. So whatever in the form of diagrams that I have showed you, all the 3 stages, whatever we have, and we are still trying to catch up with all the remaining questions. And that's it from my side. So Nikolaus, who is the designer of S-Contain, has been helpful in this, getting to all these technical details, and Jonat, Hank, and Jaren have also contributed to this work, and we thankfully acknowledge their support for this. And yeah, that's it. So if you have any thoughts or questions or any insights that you would like to share, please feel free to go ahead.
Thanks, Usama. There are a couple of questions from Greg and Keith on the chat. So if you want to.
Okay, I don't.
Well, we have just 2 minutes.
To stop sharing to see the.
Maybe we could take this. Maybe you could take these questions and move them to the chat, to the Slack channel, and have the discussion there.
Okay, sure.
Because I don't know whether in 2 minutes we're gonna have enough time to answer those.
Yeah, sure. I will put in the chat. Thanks.
Okay.
Nice job. Great summary.
Thanks very much. Oh, we need a chair for the next meeting.
I also would like to propose a topic for next meeting.
Awesome.
So I chair the GRC-SIG. In the GRC-SIG, we are nearing the completion of a governance pattern around attestation. I think we should finalize it in our meeting tomorrow morning. And after that, I'd like to send it to the attestation SIG mailing list and have it discussed. And if you want to provide offline comments before the meeting, that would be great. It's not a long document, it's just a couple of pages long.
Thanks very much. Mark, I did I understand correctly that you're going to push the document through the mailing list, or because you're coming up?
Yeah, I will send it to the mailing list. So I don't want to be, I don't want to see it, for the first time in the SIG mailing.
So we can start discussing this on a mailing list and then see whether.
Yes, exactly. That would be ideal.
Splendid. Okay. Cool.
Yeah. And I think I'll be here in 2 weeks. I can chair the meeting. So Mark, if you could add to the
I actually
agenda.
won't be. I am on vacation and far away, but I will send it. So we're going to discuss it tomorrow. So yes, please discuss it. I don't have to do that.
Okay.
Thanks, Keith. Okay. See you all in a couple of weeks then. Bye-bye.
Thanks all. Have a good day.
Bye.
Yes.
Thank you. Bye.
Thank you. Bye.